Hi, this is Bill. I want to talk to you about this Arduino Nano development board. On the development board is an AT-Mega 328P microcontroller. Around the outside of the microcontroller, you'll see these fine pins, and these connect to very, very fine traces or tracks on the circuit board, which connect to these I/O pins on the outside of this development board. Also on the board, you'll find that there's a 16 megahertz crystal. This controls the rate at which instructions are processed by the microcontroller. Next to that is this reset switch, where you can stop your program and reset it at any time. Then you'll see that there are 4 LEDs and associated 4 resistors. Next to that is a 6-pin connector. This is an ISP, in-system programming connector. At the other end of the board is a mini USB connector. Now, the mini USB connector connects to the microcontroller via an integrated circuit called a CH340 on the other side of the circuit board. Also on the other side of the circuit board, you'll see that there's a 5-volt regulator. So we can power our board off more than 5 volts if we want to. Now, let's plug this into a breadboard. Now, I need your breadboard to be oriented the right way around, the red rows at the top and the blue at the bottom. Then we're going to line up the microcontroller. Notice this gap here. I want that to line up with A2 on the circuit board. So I'm going to just line that up now. A2 will line up with that gap, which is number 30. Now, I also want 2 rows at the bottom and 3 rows at the top. This is the way I set it up on my board. So if we start from that place, that's a good way to go forward. And then you push it in, and then you've got to push it hard to get it to click right down into the board. Now, if by chance you get this in the wrong position, you can get them out again if you're very, very careful by using a screwdriver and just lifting the corners of the board very gently, just to get a little bit of lift each time, and then the board will slowly come out. And then you can just wedge it backwards and forwards to get it out. I'm going to leave it in because it's in the right place, okay? Now, we want to connect an LED to a circuit controlled by the microcontroller. So what I'm going to do is I'm going to get my LED here. There's an LED. You'll notice that LEDs have one leg longer than the other. That's because they're polarized. They have to go the right way around in the circuit. So the longer leg is positive and the shorter leg is negative. So my negative is going to go to the negative line on the bottom, and my positive is going to go to one of these columns up here. So I'm going to line it up with number 15 there. I'm going to put this positive in and the negative in, right, so that that actually inserts in the board. Now we need a resistor with an LED. 5 volts on a single LED from the microcontroller is too much. So what I've got here is a 470 ohm resistor, and I'm going to connect that in series with my LED. Now I need to connect the microcontroller to the resistor. So I'm going to use a jumper wire here from somewhere in number 15. And I'm going to take this over to B1. Now you'll notice that none of these are labeled B1. We've got D2, 3, 4, 5, 6, and 7. And then this is B0 and that is B1. So I'm going to plug that into B1. Now if you have trouble inserting these wires, they sometimes bend and they get a bit awkward. What I use often is a little sewing pin with a glass beaded head like this, and that makes a great way of pushing into the hole first, just to make sure that it's clear and it won't disturb the actual metal contacts in the breadboard. Now, we've got our resistor, we've got our LED, we've got our wire connecting it. Let's plug it in and see what happens. Now, I've already programmed this, so nothing's happening. Let's just have a little think about this. What have I got here? Well, I've got a microcontroller, which is really just a source and an internal resistance. So there's my microcontroller. And next to that, I've got a wire, and then I've got a resistor, which is 470 ohms. Now I've checked that, that's the right value. And then I've got an LED, and there's the little arrows to show that it's an LED and it's glowing. That's what I haven't got. I haven't got a rest of the circuit. Now, if you notice, this needs to be a closed circuit, and I don't have a closed circuit there because I've got nowhere for the signal, the charge to flow back to the power supply. So what I need to do is I need to connect the ground wire of my microcontroller to this ground wire here. That's great. So there's ground is now connected to ground. So what I've done is I've connected that to ground, and I've got this ground wire here, and I've got this ground wire here, but you'll see there's a gap in the middle. Let's just have a look at that gap in the middle. There's that gap in the middle. So we need to put a little link in this gap. Now I'm just going to use my little pliers because that's a convenient way. Oh, there we go. And there's my LED flashing. So now I have got a full circuit all the way around here and back to the microcontroller. A closed circuit in which has been switched by the microcontroller itself. So really you can think of this as like a software controlled switch, which is opening and closing in here. Excellent. I hope that helps you get on top of this.